Ladies and gentlemen, welcome to Puzzle X. Welcome to the quantum revolution. The next 3 days will dig deep into the latest innovations, frontier tech, including quantum computing. And quantum computing is definitely one of the hot topics, and if you may allow me, I think the hottest topic within deep tech. When I was a teenager, 14 years old actually, I read a book, In Search of Schrödinger's Cat. And actually I was blown away. So what I knew is, without understanding the mathematical concepts really yet, that if this is all true, we had to change our worldview dramatically, away from a materialistic worldview towards a holistic view of things. With quantum technology, actually, we are standing on the shoulders of giants. It were brilliant minds like Schrödinger, Einstein, Heisenberg, and Planck who actually laid the foundations of early quantum physics 100 years ago. They were finding out, for instance, that every wave can be described as a particle and every particle can be described as a wave. Wave-particle dualism. The first quantum revolution started. So what are these phenomena? And I'll do it really quick. Quantum superposition. Whereas in the classical world, every particle can be described in a distinct nature, either 0 and 1, within the quantum world, every object can have all values in between. Due to the wave character of the object, it can be in a superpositioned state. Quantum entanglement. Think about a pair of two objects which you couple, quantum entangle. You bring that one object into one end of the universe and the other object to the other end. You change a parameter on one object and immediately that other object at the other end of the universe recognizes it. It's an instantaneous connection. Einstein called that the spooky long-distance effect. Those two principles together actually create a machine which shows an exponential speed up in compute power. Think about that. I mean, I think it's the only business actually where the underlying trend is the exponential function. The exponential function will sooner or later outperform everything. That is why people are so excited about quantum computing. Well, today we understand how to build and use these machines. The second quantum revolution. 2019, I founded Terra to bring quantum out of the research labs into industrial applications. And at Terra we have one clear mission, providing meaningful quantum solutions actually today. So you might ask, why don't we find then a vast amount of quantum applications, large-scale implementations within industry? Well, actually, the technology is not yet there. Quantum hardware isn't really scalable. The native quantum chips can't really do meaningful things today. We have to wait a few more years until that quantum hardware matures. Is that a problem? Well, actually, it follows a very typical pattern. Look at the Gartner hype cycle, where kind of almost every new technology follows through. After a phase of excitement and hype, you fall into a valley of disappointment before the technology actually reaches a level of productivity for large-scale implementations. And with quantum computing hardware, we are actually almost there at the peak. So what does that mean? Do we have to wait the next 5 to 10 years to do something meaningful? I mean, the question is, how do we bridge between the hype and universal quantum computing? How do we bridge the gap? And the answer is hybrid quantum computing. Hybrid quantum computing actually will be the heating technology to make us survive the quantum winter. Hybrid means we simulate qubits on a classical high-performance computer, we enhance it with early available native quantum chips, and by creating a combined hybrid quantum machine, we run the quantum software and unlock some of the quantum potential already today. So let's jump into one specific example. I give you a specific task. We have the nearby European Alps to show you the superiority of quantum algorithms vis-à-vis classical algorithms. Well, if you are classically given the task to find out what is the highest European mountain, you would have to run up the hills sequentially, one after the other, measure the altitude, report it back, so it will be a time-consuming process. With quantum software, actually, it is very different. Think about an overarching large blanket overarching the full mountain range, which actually falls from heaven. It will immediately, when it reaches the highest peak, in that case the Mont Blanc, report back, I found the highest peak, it's a holistic approach, we can stop the exercise. That shows you the superiority of quantum software vis-à-vis classical algorithms. So what can we do with hybrid quantum computing already today? One example, think about the energy sector. The volatility of renewable energies actually in an increasing number of solar and wind mills which have to go into the energy network, it's hard to integrate. With quantum computing, actually, we can predict such capacities and stabilize the grid. One last more example, healthcare. The ability to develop drugs today is largely depending on your ability to simulate on a high-performance computer. With the power of quantum simulation will speed up drug discovery dramatically. Also, quantum simulation will help us to understand human biology at a granular level. That gives us the opportunity for specified treatments and opens the door for personalized medicine. Ladies and gentlemen, I would like to leave you today, and we hear a lot more on quantum, and I'm looking forward for all the discussions. I'd like to leave you with one clear message, which is quantum computing has left the research lab, it has arrived in industrial applications, quantum is now. Thank you.